JAM candidate, welcome to today's lesson. And please, this is my WhatsApp number if you want any material. If you want the material containing the most repeated questions in JAM UTME available in physics, chemistry, biology, you want direct mentorship, you want me to coach you for the exam, or you want lesson notes, the compressed JAM UTME 2026 syllabus, all would lead to my WhatsApp number. All right. So today we are going to be looking at molecular formula. So we are looking at calculations under molecular formula, not just molecular formula. We are also going to be looking at empirical formula. All right. Of course, for you to be able to calculate molecular formula, you have to find the empirical formula first before you'll be able to calculate molecular formula. So for JAM must repeat question 1. The question reads: a compound contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. And they give us the molar mass of each of the elements. Okay, each of the elements. All right. So finding molecular formula is very, very easy. Okay, very, very easy. First of all, let me write out all the options given. All right. So the first thing to do is to find the mole of each element. To find what the mole of each element in, the compound. Find the mole of each element, and it's very easy. So mole is equal to mass over molar mass, and here they gave us the masses in percentage. Okay, now percentage they give us all the masses. Now they give the masses for questions where they related to molecular formula or empirical formula. All right. So mole, okay, is equal to mass, okay, over molar mass. All right. So we have to find all the moles of all the elements. All right. This is how many elements? 1, 2, 3. All right. Let's go. The first is carbon. C is equal to what? What's the percentage given for C? 40%. So we put 40 over the molar mass. What's the molar mass? 12. All right. 12. And when you divide this one, it's going to give you 3.33 mole. Okay. So the mole of carbon is 3.33 mole. We do the next one. The next one is what? The next one is hydrogen. Look at it. Hydrogen equal to, what's the percentage of mass given to us? 6.7. 6.7 over, what's the molar mass of hydrogen? 1 equal to what? 6.7 mole. Okay. The final one is what? We have one more. Oxygen. Okay. Oxygen is equal to what? What is the percentage of mass given to us? 53.3%. 53.3% over, what's the molar mass of oxygen? 16 is equal to what? We divide, it gives us 3.33 mole. All right. So we are almost there. So the next thing to do now is you divide all of them by the smallest. All the moles here, you divide it by the smallest to get what? The ratio. Okay. You divide all the moles here by the smallest to get the ratio. For the first one, C is equal to, what is the smallest? The smallest mole here. The smallest mole here is 3.33. Okay, 3.33. That's the smallest number here. So we are going to divide everything by this smallest number here. Okay, so the first one is 3.33. So 3.33 over, we are going to divide everything by what? That smallest number, 3.33, is equal to what? 3.33 divided by 3.33 will give us 1. All right. So the second one is hydrogen equal to what? What is hydrogen? 6.7. Okay, so 6.7 over 3.33. That will give us what? Is about half of it now. That's 2. The third one is what? The third one is oxygen. Okay, oxygen is equal to what? 3.33. Okay, 3.33 over 3.33. That will give us what? 1. So the ratio we are having now is 1 ratio 2 ratio what? 1. Okay, so that's the ratio that we are having. 1 ratio 2 ratio 1. So 1 mole of carbon, 2 moles of hydrogen, 1 mole of oxygen. We are going to have something like this. That's our empirical formula. We can see how calculating empirical formula is so easy. So therefore, empirical formula. Okay, empirical formula is equal to C. How many more of C? 1. That's, we put it as C. H, how many more of H? 2. We put it 2. Then O, how many more? 1. We put our O. So this is empirical formula. So remember, it's molecular formula they say we should find. Since we have gotten the empirical formula, now is the time to calculate the molecular formula. So to calculate molecular formula, we have to find the mass of the empirical formula. We have to do what? Find the mass of the empirical formula. Finding mass of this empirical formula is very easy. It's just to add everything there. Okay? Adding everything here. That's what you need to do. Okay? You use this one. This is their molar mass. They add everything with here. Very, very simple. Okay? Very, very what? Simple. So C, what is the molar mass of C? Is 12. So let's do it. CH20 is equal to, we are calculating the mass now. Okay? So the mass is equal to 12. 12 is the molar mass. I mean 12 plus, what is hydrogen? Hydrogen is 1. The molar mass is 1, but it's having 2 molecules here. That's 1 times 2. Okay, so 1 times 2, which is also 2, 2 times 1, 2, plus the final one, oxygen. Its molar mass is what? 16. Okay, that's what? 16. So if we solve, we are going to have simplify this. 2 times 1, 2, plus 12 plus 16. That will give us, okay, 12 plus 2 plus 16. That will give us 30 gram per mole. So this one is the mass of the empirical formula. Okay, so for us to find the mole, because it's the amount of mole that we are going to use to what? To write the molecular formula. That's why it's called molecular formula. Molecular formula. For us to find amount of mole, that's why we have to find this mass. Okay, so that we use it to find the mole. So what is the formula for mole? N, which signifies mole, is equal to what? Molar mass over the mass, okay? And the mass we are talking about here is the mass of the empirical what? Formula. The mass of the empirical formula is what? Okay, let's just put it. Mass of empirical formula. Empirical formula. The mole is equal to what? The molar mass over the mass of the what? The empirical formula. So therefore, to finish this up, we are going to have N is equal to what is the molar mass? The molar mass of the entire compound. Okay, it was mentioned in the question. Okay, it said if the molar mass of the compound is 180. Okay, this one is the molar mass 180. So 180 over what is the mass of the empirical formula? 30. So 180 divided by 30 will give us, that's 6. 180 divided by 30 will give us 6. So 6 is the number of mole. So how are we going to use this number of mole to write the molecular formula? Very easy, okay? Your empirical formula, just put your empirical formula inside brackets and put the mole there. It will not be times the mole. So our empirical formula is this, CH2O. Then put it inside brackets. Then the number of mole, put it here, 6. So this is what your molecular formula. So if you want to rewrite this, you want to expand this because it's compressed, what it means is that 6 will times everything you have inside here one after the other. So let's now expand the formula. Okay, because if you look at the formula in the option, the molecular formulas in the option, all of them, they expand all of them. Okay, so if you want to expand this one, that will be 6 times C, we will have C6. Okay, 6 times H2, remember H is carrying 2, it has 2. 6 times H2 will give you what? 6 times 2 will give you 12, that's H12. Then 6 times O will give you what? O6 or 6O. So this is the what? The molecular formula of this particular compound. So among the options, pick the correct option and drop it in the comment section. This is the molecular formula of glucose. All right. So JAMB can still ask you what compound, okay, has the so after calculating, they will represent everything with name of compound. Is it glucose? Is it fructose? Is it lactose? Is it this one? Is it methane? Is it and so on and so forth? They will ask you. So you should be able to know the molecular formula of common compounds. Okay. Let's move on to the next topic.